Hello friends, today's question. A horizontal stressed string fixed at two ends is vibrating in its fifth harmonic according to the equation y of xt equal to 0.01 meter sine of 62.8 meter inverse x cos of 628 per second t. Assuming pi 3.14, the correct statement is or r. So it is a multi-correct option. So in the first, we have to find out what will the number of nodes. Then we are going to find the length of the string. Then the maximum displacement at the midpoint, as well as the fundamental frequency. So in this case, we are going to make a comparison of the given equation with the standard equation. And from there, we are going to find out what will be its wave number, as well as the angular frequency. And then we can find out the various things which we are required to find out. So let's start with the standard equation. So we can say the standard wave equation it is given as y of xt is equal to a sine of kx multiplied by cos of omega t. And let us write the given equation. Given equation, we have y of xt is equal to 0.01 m sine of 62.8 per meter x multiplied by cos of 6 to 8 per second t. So for in the general equation, we can say that our A is the amplitude and if we make the comparison with the given equation, we can say that the value of A will be equal to 0.01. K is our wave number which is also given as n pi upon lambda, and in the given equation we can say that value of a wave number will be 2.8 and omega is our angular frequency and we can say that this will be equal to 628. So in the first part, we are supposed to find out in the A part that the number of nodes. Okay. So let us find out the number of nodes. And in the question, it is mentioned that the string is vibrating in the fifth harmonic. Okay. So you can write the string is vibrating in fifth harmonic. So we can say value of n is equal to 5. Therefore, the number of nodes when the string is fixed at both ends and in the nth harmonic it is given as n plus 1. So we can say for a string, fixed at both ends, vibrating at nth harmonic, vibrating at nth harmonic. For it, we can say that number of nodes will be equal to n plus 1. And for the given question, the value of n is equal to 5. Therefore, we can say that number of nodes will be equal to 5 plus 1, that is equal to 6. So in the option number A, it is given that number of nodes are 5, so this option is incorrect. Now let us find out about the next part. For that, we can say that what will be the length of the string. Length of the string. And we know already that wave number is we found out that wave number is k, and so we can write that our k will be equal to n pi upon l, and value of n is our 5, so this becomes 5 pi upon l, and wave number is our 62.8. We can say value of L will be equal to 3.14 divided by 62.8. So this gives us that the length of the string will be approximately equal to 0.25 meters. So the option number B is the correct option. Length of string is 0.25 meters. Now next, let us find out the fundamental frequency which we are required to find out. D part, then we come back to the C part. Fundamental frequency. So we can say our F1 will be equal to V upon 2L, and our V is our wave speed, and our wave speed is equal to omega divided by k. Omega we already know is our 6 to 8, and k is our wave number, so we substitute the values. We get this as 6 to 8 divided by 62.8, which gives us 10 meter per second. Length we already calculated, so F1 will equal 10 to 0.25, and this gives us that our fundamental frequency will be 20 Hertz. So option number D is the fundamental frequency is 100 Hertz. Once again, Next is our maximum displacement, which we are supposed to find out. So we can say that our maximum displacement at the midpoint from its equilibrium position. Maximum displacement of the midpoint from its equilibrium position. Equilibrium position. So we are given the equation, let me write it again, that y of x comma t is equal to 0.01 meter, and here we have sine of 62.8 per meter x, cos of 6 to 8 per second multiplied by t. And from here we can easily say that our amplitude A will be equal to 0.01 meters. So which corresponds to maximum displacement at any point on the string. So this value of A, it corresponds to maximum displacement at any point on the string. Now we have to find out, or we can say verify, that it is said to be at the midpoint of this. So let us find out the midpoint. So you can say the midpoint of the string let us suppose that is x will be equal to L by 2. Value of length we already know is our 0.25, I think, yeah, 0.25, and divided by 2, which comes close to 0.125 meters. So therefore we can write the given equation as y of 0.125 with respect to time t, it will be coming as 0.01 sine of 62.8 multiplied by 0.25, and we have cos of 6 to 8 multiplied by t. So from here this value will be coming as approximately 7.85. So we can rewrite this as equal to 0.01 sine of 7.85 cos of 6 to 8 multiplied by t. So at maximum displacement, the value of the partial function, which is cos of 6 to 8t, should be equal to 1. So we can write that at maximum displacement, we should have cos of 6 to 8t should be equal to 1. And the displacement is given by the amplitude, multiply by, so we can write that our maximum displacement now will be equal to 0.01 sine of 7.85, or for the sake of simplicity, let me write, let it be like this only. So for maximum displacement, it should be 0.01 sine of 7.85 and its maximum value. And maximum value of sine is 1. Therefore, we can say that this will be equal to, I can write it here only, you can say that maximum value of sine 7.85 is equal to 1. Therefore, we can say that one second, got stuck. Yeah. So we can say that the maximum value of sine of 7.85 is equal to 1. Therefore, we can write that our maximum displacement will be equal to 0.01 multiplied by 1, which comes at 0.01 meters. So this is the maximum displacement at the midpoint. Maximum displacement at the midpoint. So therefore, the option number C is also correct. Option number D is incorrect because the fundamental frequency is said to be 100 Hertz, whereas we found out that the fundamental frequency is our 20 Hertz. So this completes the question. Thank you.